So hello everyone. So in this video I'll discuss the AC parameters of common gate MOSFET amplifier. So in the common gate the input is applied at the source terminal and the output is taken from the drain terminal, right? Now first AC parameter, that is the current gain. Internal current gain, that is internal output current upon internal input current, right? So obviously because ये common gate है तो यहाँ input current जो है वो basically सोर्स टर्मिनल पे अप्लाइड है तो यहाँ पर ये करंट गेन जो है वो एग्जिस्ट करेगा, राइट? बिकॉज अनलाइक इन द केसेस ऑफ कॉमन सोर्स एंड कॉमन ड्रेन, बिकॉज वहाँ पर इनपुट करंट जो वो गेट करंट था, सो इसलिए वहाँ पर इंटरनल जो करंट गेन था वो एग्जिस्ट नहीं करता था, मतलब इनफाइनाइट था। सिमिलरली जो इनपुट रेजिस्टेंस था वो भी इनफाइनाइट था, बट यहाँ पर ये दोनों एग्जिस्ट करेंगे, राइट? सिमिलरली वो स्मॉल सिग्नल वोल्टेज गेन और इनपुट रेजिस्टेंस है वो तो एग्जिस्ट करता ही है, ठीक है? तो लेट्स स्टार्ट विद द current gain, right? So first of all I am making the RE model by pausing the video. So ये basically RE model है, right? अब देखिए यहाँ पर we have to find out the current gain, right? ये but internal current gain है, ये internal current gain है इस MOSFET amplifier का common gain, right? So internal current gain will be the ratio of the internal output current upon internal input current, right? अब यहाँ पर what I want to explain here that ये जो आई आउट करंट मैंने ड्रॉ किया है, ये जो लोड रेजिस्टेंस में फ्लो हो रहा है, राइट? यहाँ से इस लोड रेजिस्टेंस में ये ड्रेन रेजिस्टेंस है और ये दोनों पैरेलल हैं, राइट? सो आउटपुट बट आउटपुट करंट तो केवल इस लोड रेजिस्टेंस में से फ्लो होगा, राइट? बट जब इंटरनल करंट गेन की बात हो रही है तो दिस इज नॉट द इंटरनल आउटपुट करंट ऑफ दिस मॉसफेट। जो इंटरनल आउटपुट करंट है इस मॉसफेट एम्पलीफायर का वो बेसिकली यहाँ से फ्लो होगा, दैट इज माइनस आईडी, जो बेसिकली इन दोनों के पैरेलल कॉम्बिनेशन के अक्रॉस फ्लो होगा, right? So I think this point is clear. अगर clear नहीं है तो you can definitely ask in the comment section. So इसलिए मैंने यहाँ पर ये different parallel combination के साथ नहीं बनाया to explain this. तो ये basically जो internal current gain है it will be internal output current, right? Which is minus ID, right? और यहाँ पर जो internal input current है वो तो basically यही है, right? और ये basically in terms of this ID is minus of ID. So यहाँ पर it will be I should write first I now यहाँ पर this will be minus ID and upon this will be minus ID. So this is 1, right? So the internal current gain, the common gate MOSFET amplifier is unity, right? And that is why the common gate MOSFET amplifier is known as the current buffer amplifier, right? The common gate MOSFET amplifier is known as the current buffer amplifier or current buffer circuit because the current gain of this amplifier is unity, right? So this is a good point. Now ये तो था internal current gain, right? अगर if we want to talk about the current gain of this circuit, then this output current will be I out, right? अब यहाँ पर जैसे if we want to talk about the current gain of the circuit, so यहाँ पर it will be I out and upon input current, right? So यहाँ पर this should be clear कि क्या पूछा जा रहा है, कि वो internal current gain पूछ रहे हैं या फिर सर्किट का current gain पूछ रहे हैं। तो यहाँ पर then it will be I out upon I. अब यहाँ पर the I out we have to apply a current division rule across this, right? So I out will be minus ID into RD upon RD plus RL, right? तो यहाँ पर first of all I out will be by current division rule minus ID and into RD upon this will be RD plus RL, और जो इनपुट करंट है वो तो बेसिकली माइनस आई डी है, राइट? तो सिंपली जो ये करंट गेन है सर्किट का वो सिंपली क्या हो जाएगा, ये दोनों कैंसिल आउट हो जाएंगे ना, आर डी प्लस आर एल, जो कि प्योरली इनके वैल्यूज पर डिपेंड करेगा। सो इस तरह से दिस इज द करंट गेन ऑफ द सर्किट, राइट? एंड दैट वाज द करंट गेन ऑफ द इंटरनल करंट गेन ऑफ द कॉमन गेट MOSFET एम्पलीफायर. सो आई थिंक इट इज क्लियर. So अब यहाँ पर this is the current gain. अब let's discuss about the internal input resistance, right? So for internal input resistance, I'm again redrawing the RE model. So by pausing the video, so internal input resistance. So it will be internal input voltage upon internal input current, right? So क्या ये जो input है, क्या ये internal input voltage है MOSFET के लिए? So obviously it is not the internal input voltage because यहाँ पर ही source resistance present है, ये directly connected नहीं है source से, right? तो इस वजह से ये इंटरनल इनपुट रेजिस्टेंस नहीं है. We have to let voltage here, let us behind dash. So this is the internal input voltage of this common gate MOSFET amplifier. We can understand like this. यहाँ से so we can draw like this. This is the VIN, this is RS, and this is VIN. So this is the internal input voltage, and we are seeing the internal input resistance from here, right? This is the internal input resistance, which is this will be VIN dash and upon this input current, which is IN, right? Which is flowing in this direction. Now for calculating this input resistance, obviously we have to apply a KCL at this VN dash, right? So first of all, this VGS in terms of VN dash, it's close to minus VN dash, right? So this is the यहाँ पर when you apply KCL, so if you apply KCL, it will be minus GM VGS, right? So minus GM and VGS in terms of VN is minus VN dash, so it will be plus GM VN dash, right? Then this current is incoming, so it will be minus of IN, then plus VIN minus V naught plus VIN dash minus V naught upon R naught is equal to 0, right? अब यहाँ पर this ID current is going in this direction, so minus ID will be flowing in this direction. So V naught is, अब यहाँ पर I have taken the parallel combination because ये जो IO का जो concept था I have explained it here, right? तो इसलिए मैंने यहाँ parallel combination ले लिया. So V naught will be minus ID into RL dash. We have to substitute this because we want only two terms, that is VN dash and IN, right? So यहाँ पर this will be, or this minus ID will be IN because, right? Because ये जो IN है so is equals to IN into RL dash, right? अब ये two values, these value and this value we will substitute in this. So यहाँ पर KCL, so it will be GMVN dash and minus IN, and it will be plus VN dash upon R naught and minus of V naught. Minus V naught means minus IN dash, minus IN upon RL dash and upon this will be minus IN into RL dash and upon R naught, right? Now यहाँ पर VN dash will be common, then this will be GM plus 1 by R naught, right? So 1 plus GM R naught upon R naught and equals to, this will be IN, and यहाँ पर 1 plus RL dash by R naught, it will be IN and R naught plus of RL dash and upon R naught. Now these will be cancelled out, and VN dash upon input current will be R naught plus RL dash upon 1 plus GM R naught, right? So ये basically यहाँ, this is the internal input resistance, this one. अब यहाँ पर if this R naught is high, right? If it is high, then we can simply neglect it, right? By taking common. So यहाँ पर when we take this common, so it will be R naught and 1 plus RL dash upon R naught, right? And यहाँ से GM plus 1 down, right? This is a very high value, so this will be neglected and this will also be neglected. So the input resistance will be equal to 1 upon GM. So this is the approximation we can say when this condition is true, right? So this is the internal input resistance. So I hope it is clear, and it is seen from here. I should write here also, जैसे यहाँ से, so basically यहाँ से we have seen the internal input resistance जो यहाँ से देखा, right? और अगर if we see from here, so it will be RN dash, we can say this is not the internal input resistance, it is the input resistance of the circuit, which will be this RS and plus of R, right? So I hope it is clear. And यहाँ पर भी we should write this यहाँ पर, so the R dash is equals to RS plus of R. So this is of circuit and this is internal. Now the small signal voltage gain. So अब यहाँ पर small signal voltage gain के लिए यहाँ पर this is the circuit, right? So we have to find out the V naught upon V index. So we can apply a KCL at this V naught for finding this small signal voltage gain. Small signal voltage gain, that is V naught upon V index. We will apply KCL at V naught, right? KCL at V naught. So it will be, this will be V naught upon RL dash, right? Then plus V naught minus Vn dash upon R naught and plus GM VGS. And VGS is equals to minus of Vn dash, right? तो यहाँ पर देखिए, so V naught upon RL dash, then plus V naught minus of Vn dash and upon R naught, then plus GM VGS, right? is equals to 0. So यहाँ पर this will be V naught and 1 upon RL dash plus 1 upon R naught and minus Vn dash upon R naught and plus GM VGS. So it will be minus of GM and Vm dash, right? So to 0. So यहाँ पर V naught and this will be R naught into RL dash, R naught plus of RL dash is equals to Vn dash and 1 by R naught plus GM, right? So it will be Vn dash and 1 plus GM R naught, and R naught will be cancelled out from the denominator and it will be R naught plus of RL dash and upon RL dash. So V naught upon Vi will be V naught upon Vi dash, it will be 1 plus GM R naught into RL dash, 1 plus GM R naught into RL dash upon R naught plus RL dash. So this is the small signal voltage gain, and this is how we can find out by just simply we have to draw the model and apply the KCL and do the substitutions, right? अब यहाँ पर again, if this R naught is infinite, means the channel length modulation parameter is 0, that lambda is equal to 0. If it is infinite, then we can write like this: V naught upon Vn dash, it will be simply GMR dash, right? जो basically काफी known result है, जो याद रहता है, that is common gate MOSFET amplifier के लिए, that is GMR dash. But पता होना चाहिए कि this, if this condition is true, then only this result is valid, that is GMR dash, right? So this is about the small signal voltage gain. अब the last parameter, it is the internal output resistance, right? अब इसके लिए I have to again draw the model, RE model, by removing the input supply, right? And VDC upon IDC by substitute the output voltage as VDC. So I'm pausing the video. So we have removed the input supply, right? And replace the output V0 by a voltage VDC and the current flowing is IDC, right? अब यहाँ पर for R0, that is VDC upon IDC, when the input is removed, right? So यहाँ पर this IDC is nothing but equals to ID, right? That's the drain current. So we have to go with the case. We can go with the KVL, right? यहाँ से इस loop में we can go with the KVL as इस तरह से. In this loop we can apply the KVL easily. And first of all, the relation between, say we see the relation. So VGS is equals to minus ID into RS, right? यहाँ से if we see the relation, so यहाँ पर VGS is equals to minus of ID, which is equals to, this is nothing but IDC. ये जो ID है current, that is equals to IDC, so minus IDC into RS. This is the VGS, and when you apply, और यहाँ पर इस R0 में से जो current flow है, this is the IDC current and this is the GM VGS. So यहाँ पर जो current flow है, this is the IDC minus of GM VGS, right? So when you apply KVL, so it will be minus VDC, then it will be plus of IDC minus GM VGS. Now VGS is this one minus IDC, so it will be minus IDC and into RS, right? So then this whole will be into R naught, and plus IDC into RS is equals to 0. So VDC is equals to, it will be IDC, and IDC will be taken common, right? So R naught, then plus of GM RS R naught, and plus of RS, right? So here we have got the internal output resistance, that is VDC upon IDC. It is, if we take the R naught and plus, if we take RS common, so it will be 1 plus GM. So this is the internal output resistance which we have seen from here. यहाँ से we have seen, यहाँ से, this is the R naught, that is VDC upon IDC. So this is how we can analyze this common gate MOSFET amplifier and derive these results, right? So I hope it is clear, and if you have any doubt, so you can easily ask in the comment section. So okay, thank you.